on this first one here, find the point on the hyperbola, xy equals 8, that is closest to the point 3, 0. So, is this your constraint or what you're trying to minimize or maximize? This is the constraint. Nice, okay. So that's the constraint, so closest to the point 3, 0. So you have to write the distance from the point 3, 0 to the point xy. So what's that going to be? X minus 3 squared plus y minus 0 squared, and it's the square root of that. Is that correct? Yeah? This is what you are trying to minimize or maximize. Minimize, yes. You're trying to minimize that right there. It's true. So what do you have to do first if you're going to minimize that? What's the problem? Solve the constraint for? So what's the problem with this? What's the problem? Why can't you just use this right now? Too many variables. So you want to bring it down to one variable. So you take this right here, and you get what y equals 8 over x. So now you have the distance just in terms of x. And I'm going to multiply it out. X squared minus 6x plus 9 plus 64 over what? And it's the square root of this, correct? Right? So now what do you need to take of this? So you're going to end up with 1/2 x squared minus 6x plus 9 plus 64 over x squared to the what power? Times 2x minus 6 minus 2 times 64 times x to the negative 3, right? Is that correct? Now we're interested in when this equals what?
0.
You're interested in when this equals 0 right there. So you really don't care about the denominator, so what's the only thing you really care about? That's the numerator right there. So you're interested in 2x minus 6 minus 128 over equals 0, and I see where you're going to get the quartic from. What did you multiply everything by? So you got 2x to the 4th minus 6x cubed minus. And before you try to do anything else, what might it be nice to do to this? Yeah, you can divide by 2 in this case. It's okay, but yeah, I like factoring is safer generally, right? So what do you end up with? 2 times x to the 4th minus 3x cubed minus equals. So you ask yourself, is this nicely factorable? Is there something that multiplies together to get 64 that adds together to get negative 3? No, so you're going to do b squared minus 4ac. So if you were doing this by hand, you find the discriminant. So 9 minus 4 times 1 times negative 64, which is equal to 9 plus 256, which is 265.
You can use the quadratic in a quartic.
Oh, I'm sorry. I haven't really explained this to you. Excuse me. Let me pause. It does not work in this case. It does not work in this case. So you can't do this. Because why can't you do this? This is not a. The way I call it is it's not a. I just call it a fake quadratic. It's not.
Squared?
No, you can't. So what really you have to see if you can factor this, but if you can't factor it, what are you going to have to use? You're really just going to have to use your calculator on this. So let's actually use zoom fit here. Is 0? It's 0. Let's see what comes up. Is zoom fit always a good thing to use? Not always. Here's what it looks like right here. It's also hard to tell what's going on right here. You know what I mean? Okay, so we're going to zoom box all the way around this. So how many zeros does it look like it have? 2 of them. What do you use on your calculator to find those zeros? Not mins. We're not looking for the min of this function. We're looking for intercepts, right? So like literally on your calculator, second calc, what do you have? What do we have? 0. And it wants the left bound, so let's go to the one to the right here. You have to do a lot of clicking, unfortunately, sometimes. It's just the way it works. And now it's going to go off the screen and redraw it. Okay, great. Now, where's the guess? Let's put the guess right there. 4. 4. What does that tell us about this polynomial? It's nicely factorable. It is nicely factorable. So let's go back. So if that tells us it's nicely factorable, let's go back and just take a look at this polynomial for a sec. Right here. If we want to factor this, do you remember what you have to do if you want to factor this? Yeah? Potential rational zeros. Do you remember that at all? Do you remember potential rational zeros at all? No? What are all the factors of 64? 1, 2, 4, 8, 16, and? That's the 32 as well, right? And 64. What are all the factors of the leading coefficient? 1. At least the leading coefficient is 1, right? The potential rational zeros of this polynomial are plus or minus 1, 2, 4, 8, 16, 32, and 64. How many potential rational zeros is that? That's 14 of them, right? So you have to start testing them. Do you remember testing potential rational zeros by any chance? No? I'll show you. We already used our calculator, so at this point we would finish it, right? Does it look like our left zero is going to be any good?
No.
Not really, but it's gonna. If we pull it out, it might be a cubic, and it's even nastier. But if we wanted to factor this, do you remember this? 4, and then 1, -3, 0, 0, and is it negative 64 or 64? Negative 64. You drop the 1 down, you get 4, 1, 4, 4, 16, 16, 64, and 0. So what does it factor into? X minus 4 times x cubed plus x squared plus 4x plus 16. And this helps us because we factored out one term. But this right here, this cubic, is that cubic guaranteed to be nicely factorable? No, and it probably isn't because look at that left bound over there, right? So let's use the calc again. If we've already committed to using the calc function here, what's our 0 going to be? And the problem is, we now know that from here to here, the derivative is positive, and from here to here, it is positive. So f prime of x is greater than 0. F prime of x is greater than 0. What happens in between? It's negative. So this is f prime of x is less than 0. So at this point right there, at point A, and there's point B here, the function is increasing, and then it is decreasing, and then it's decreasing, and then it's increasing. So which one is going to be a minimum, A or B?
B.
B is a minimum, and A is a maximum. So it happens at x equals 4. Now, one thing we can do to check this, and because the question is asking, I think, what point, right? So what's the point? If x is 4, what's y?
2.
2. So y is 2. What could we do in order to check this?
You just take this second derivative.
No, I don't want to plug anything in. I don't want. What's the first? When you did word problems in Algebra 2, what was the first thing you generally had to do if it was describing a complex situation? Before that.
Simplify.
Before that. Now?
Yeah.
Okay. So that actually is a circle draw tool, but I'll see if I can get better at this. Oh, that's not bad. Circle. And this circle has a radius of r, and what are we going to put around it? We're actually drawing the Deathly Hallows. Nice. See this now? Circumscribed about a circle. It would have said circumscribed inside a circle. It would have said the circle circumscribes the triangle if it was going to draw what you have, okay? So what do we know? What's the distance from here to here? R. From here to here. Let's just draw some stuff in here. R. And it says find the smallest possible area of an isosceles triangle that is circumscribed about a circle of radius r. So what do we need to write here? We need to write an equation for the area of the circle in terms of the area of the triangle in terms of r. We want to do the area of the triangle in terms of r. That's our goal. If we get that, we want to minimize that function, right? So you need to figure out how to find the area of this triangle right here. Any idea how I can do that? What else can I draw in there, do you think? Or what should I draw in? Any other ideas? Let's call this the center. Let's call this point, I don't know. Let's call this point F right here in the center. What else can I draw in? What other points? If this is point F. What other line should I draw in, kids?
The one between the top of the circle and the top of the triangle.
Let's call this, I don't know, B. Let's call it B, C, and D. What line should I draw in, do you think? Kids, you can draw in any line you want. Here's one thing you need to get better at: just doing something and seeing if it works. Okay. What should I connect? Do you think? B and F. How would I connect all these?
Yeah. Because then you could get.
All of these. Well, excuse me. Here's the thing. Do you know if this is an equilateral triangle?
No, it's an isosceles.
It's an isosceles triangle. It's an isosceles triangle. So what do we know? We know that this and this are this. Well, we know actually we don't know that. We know that. Yes, it's funny because that makes me less frustrated. Yeah, you guys learn your lessons real well. Good listening comprehension. We now know that BD is equal to what?
BC.
BC. So that's what we're assuming for isosceles right there. Okay?
But then,
That's all we know. We don't know if this is an equilateral triangle.
if
Then BF equals C.
CF maybe equals to FC.
We know that BF.
BF.
No, we don't know that.
BF.
Kids, it's an isosceles triangle, so it could look like this. It could be really tall. Look.
Yeah, but two of them are the same.
Correct, but the center from here to here is not equal to that.
No, he's saying D to F.
Oh, D. I'm sorry. Yes, you're absolutely right. So this right here is congruent to that right there. That is correct. Yes. Okay.
so that, wouldn't you, because that's perpendicular. R is perpendicular to BD. Right?
R
The
is perpendicular.
radius coming from F, the left top radius. Right. So then that's 90 degrees.
Yes, you all know. You know that these are 90 degrees. That's correct.
Right. So then.
You know all these are 90 degrees. That's
Then-
correct.
then the-
Couldn't you do
You know that this is congruent to this is congruent to that. Yes.
so? Like, the
You do know. You know that this right here is congruent to this right here.
yeah, so,
right?
So the D to the center of the
You need to write the equation for the area of this triangle. Any ideas?
In terms of just R?
Yes, in just R. Correct. I'll give you a hint. You're not going to be able to probably do this by just trying to get to the final equation. It's the most common mistake kids in Algebra 1 and 2 make. They see a word problem, they try to construct the formula like immediately. They don't try to do any legwork or any other observations. You guys need to write 1/2 base times height. That's correct. So you want this distance, correct? You want from D to C? That would be your base. So let's call from here to here Y. Okay? Is that just giving you something to go with? And let's call from the height here. Let's call that X. So if we call our height X, our height is X, our area is going to be 1/2 2Y times what? And we're trying to minimize that. Correct? We're trying to minimize the area. Does that make sense, everybody? Okay, so you now need to use a whole lot of, well, actually just one in particular, similar triangles. Similar triangles, and I'll show you what happens. Here you go. If that height is X, you know, let's call this point, I don't know, Q right there. From X, what's the distance from F to Q? From the center of the circle to Q? R. Therefore, what's the distance from F to B? If the height, remember the height is X.
Minus R.
So you know that the distance from here to here is X minus R. Right there. Everybody sees that? Here's the relationship that you can write. Y over X is the base of this triangle right here to the height. Everybody sees that? Yeah, kind of, maybe, sort of. So you want the base, and what you're going to do is compare it to this triangle right here. That triangle right there. So the thing is, you need to find the distance from B to, what do you want to call that point? J. How do you find the N? How do you find the distance from B to N? How do you find the distance from B to N? You know that BNF is what kind of triangle?
R squared plus F minus R squared.
You know that R squared plus the distance from B to N squared is equal to X minus R squared, correct? So you know that BN is equal to the square root of X minus R squared minus r squared. Exactly, right. Nice, nice, nice. So what this allows you to say, there's two triangles here, and this is a lot harder than I thought it was going to be. Y, the base to the height is the same thing as the base to the height right here. The base to the height right here is the same thing as the base to the height right here. How do you know that those are similar triangles? It allows you to write this. The base of the big triangle over the height of the big triangle is equal to the base of the smaller triangle over the height of the smaller. And here's the thing. Your answer is going to have r in it. So is it okay if r is right here? Yeah, and so this right here is our constraint. So this is a tough question. And what was the function we were trying to minimize? Area in terms of x and y was what? 1/2 times 2y times x, because y was half the base of the big triangle, right? So here, what should we multiply both sides by here? What should we isolate from that first constraint? Y. So we multiply both sides by, so we know y is equal to rx over this thing. So where do you plug that in? You plug it in right there, and what do you get? Area in terms of just what? Yeah, you know, r is treated like a constant, so it's just along for the ride. R is the number 8 for all intents and purposes. Okay, it doesn't change. So what is a of x going to be? 1/2. Well, actually times 2. So what happens here? It's just xy. You're absolutely right. So it's going to be rx squared all over, because I'm multiplying this whole thing by x. X minus r squared minus r squared. And now what do we take? The derivative. A prime of x is going to equal
1x and 1r.
Well, we have to be really careful. There's 1x and 1r. Okay, so r, you mean like rx, like this? So it turns into 2 times, and I'm going to multiply this out, x squared minus 2xr plus r squared minus r squared. That's this part right here, to the what power? 1/2 minus what? X times, oh, and you know what? I'm going to cancel out this 1/2 with these, the 2 2's right there. I'm going to factor out the 2 to the outside. So what do you end up with on the inside here? X squared minus 2xr plus r squared minus r squared, and on the outside times what? X minus r. Well, actually this collapses kind of nicely. It's pretty bad though. What collapses on the inside here? Those are gone. Those are gone. That's kind of cool.
Can you do that
Can you
with the 2? Can you do that with the 2? Because,
you mean right here?
Because it's within the negative 1/2.
Oh, is it in within the one? No, it's not within the 1/2. It's
No,
outside.
that is.
Okay, hold on a sec. Sorry, kids.